Hello friends, welcome in online lecture of fluid mechanics subject. Myself Mitesh Patel. I am an assistant professor in a mechanical department at the Dr. Subhas Technical Campus, Junagadh. Today's our lecture topic is a Bernoulli's principle. So let's start the lecture. Okay. First see the statement of Bernoulli's principle. What it said. In an ideal compressible fluid, when flow is steady and continuous, the sum of pressure energy, kinetic energy and potential energy is a constant. So we can say that in short, the total energy of fluid at any point is a constant. But in total energy, we can count the only three energies: pressure, kinetic and potential energy. Okay. So mathematically, we can write this where pressure energy, velocity energy and potential energy. So pressure energy is equal to P upon rho g. So we can know that rho g is a specific weight small w. Okay. And kinetic energy equation is a V square upon 2g. And Z is a potential energy or datum energy. Okay. Now we prove the equation of Bernoulli principle. This equation we prove that. Now consider the ideal incompressible liquid flow through the non-uniform pipe as shown in figure. The cross section of pipe is not uniform as per mentioned. Now consider the two section LL and MM onto the pipe and the flow is continuous and continuity. Okay. Now P1, V1 is a pressure and velocity at a LL section. Similarly, P2 and V2 is a pressure and velocity at a MM section. Z1 is a datum height of a pipe center at a LL section. Similarly, Z2 is a datum height at a pipe center at a MM section. Okay. Now A1 is a area of LL, cross section area of pipe at a LL, and A2 is a cross section area of pipe at a MM. Okay. Now liquid between the two section LL and MM move to LL dash and MM dash, LL to LL dash and MM to MM dash at a very small length DL1 and DL2. Okay. Now movement of liquid from L to LL dash and M to MM dash are equivalent. So weight of liquid between the two section L and LL dash, M and MM dash are equivalent. Okay. So now consider only L side. The weight of liquid between LL and LL dash section, that can be mentioned by this way. We know that W is equal to mg. So M is converted into the density and volume. So rho Vg. Now we rearrange rho g V. Rho g, we know that it's a specific weight small w, and now put the value of volume. So we know that cross section area at LL side is a A1 and length DL1. So A1 and DL1 is a volume and weight small w is a specific weight rho g. So rho g we can write this way: small w into A1 into DL1. So W is equal to small w A1 and DL1. So we can get the equation 1 of the ratio of weight to specific weight is equal to A1 DL1. Okay. Now similarly we can get the similar equation according to weight ratio, weight upon specific weight, A2 into dl2. So we can say that according to equation 1 and equation 2 we compare that, then we can get this value A1 dl1 is equal to A2 dl2. This relation we can get. Okay. Now work done by pressure to move the liquid from L to LL dash. So work done is equal to, know that, force into distance. So according to pressure the work done is formed. So force is a pressure force equal to pressure into area. Okay. So P1 and A1, and distance is a, we know that, small dl1. Okay. Similarly, work done by pressure at a mm section to move the liquid from mm to mm dash. Okay. So similarly, pressure force P2A2 and distance dl2, but the negative signs mention that the pressure P2 is applied into the opposite direction to P1. Okay. Now potential energy, we know that the equation of potential energy mgh. We can write h or z. H is mentioned the height, head height, and z is also the mentioned the z height. Okay. So we can write mgz. So mg is equal to, we know that, weight. So weight into z is a potential energy. Now kinetic energy equation we also know, 1/2 mv square. Okay. So we can multiply and divide into this equation of kinetic energy by g, multiply and divide the g. So we can get the mg v square upon g 2g, sorry, mg v square upon 2g. So mg is equal to, we know that, weight. So equation become a weight into v square upon 2g. Okay. Now we can take the total work done by pressure, so is equal to P1 A1 dl1 minus P2 A2 dl2. So we know that A1 dl1 is equal to A2 dl2. So we take A1 dl1, write A1 dl1 against to A2 dl2. Okay. So we can take a common A1 dl1. So in bracket only P1 minus P2. Now we know that A1 dl1 ની value શું છે? What is the value? We can get that W upon small w, weight upon specific weight. So put this value in A1 dl1. So equation has become this. This is the equation of total work done by pressure. Okay. Now loss of potential energy. Potential energy is lost when liquid is moved from M to MM1 and L to LL dash, because the height is reduced. That's why potential energy is reduced. Okay. So what is the loss of potential energy? We can get from difference WZ2, WZ1 minus WZ2. Okay. So W is common. So we can get the loss of potential energy by W into Z1 minus Z2 equation. Okay. Similarly, gain in kinetic energy. We gain the kinetic energy because during the movement of fluid, pressure energy is decreased, potential energy is decreased. So we know that the pressure energy is decreased, then velocity energy is increased. Velocity is increased. So velocity is increased, then we can say that the kinetic energy is also increased. Okay. So gain in kinetic energy during the movement of fluid, LL to LL dash or MM to MM dash. What is this? the difference between the kinetic energy at a section 2 minus section 1. So we know that the value W into V square upon 2G, kinetic energy at a section 2 minus section 1, W is take a common, so V square upon 2G minus V square upon 2G. Okay, so this is the equation of kinetic energy, gain in kinetic energy. This is the equation of loss of potential energy, and this is the equation of total work done by the pressure. Okay, now according to flow, we know that the potential energy is decreased, pressure energy is decreased, and due to that the kinetic energy is gained. So we can write that the gain in kinetic energy is equal to loss of potential energy plus work done by pressure. Okay, so put the value of all kinetic energy, work done by pressure, and potential energy. Okay, now W means the weight is nullify in both sides. Okay, now the remaining equation is this, and now rearrange the our element of the equation. So one side or L side elements are moved to the left side, and two like second section side na element આપણે right side લઈ જઈએ. બરોબર છે? So we can get this equation, and this is the fulfill the statement of Bernoulli, and we can get the Bernoulli equation. So this is say that the energy at a section 1 or L is equal to the energy of at a section mm. So it's hence prove the Bernoulli equation. Okay. In this principle, some assumptions are taken. These are listed below. First one is the liquid is ideal in incompressible. We already discussed in a statement. And the flow is steady and continuous. Flow is along the streamline, means it's considered as a one dimensional. Velocity is uniform over the section and equal to the mean velocity. Okay, the only force acting on the fluid are the gravity force and pressure force. Only two force are considered, losses are not considered. Okay, these are the assumptions are considered into the Bernoulli's principle. Okay, now solve the some problems of Bernoulli's principle. So first problem, the data is given, the water is flowing through the pipe having a diameter 20 centimeter and 10 centimeter at a section 1 and section 2. Okay, 20 centimeter diameter and 10 centimeter diameter at a section 1 and 2 respectively. The rate of flow through pipe is a 35 liter per second. So rate of flow is given, so we can say that Q is equal to 35, okay, liter per second. The section 1 is 6 meter above the datum. The center of section 1 is 6 meter above from the datum line, and similarly section 2 center is 4 mm above from the datum line. If the pressure at a section is 39.24 Newton per centimeter square, then find the intensity of pressure at a section 2. So we have to find out the pressure intensity at a section 2. Okay. So now let's list the all values which are given into the data. D1 20 centimeter, so convert into the meter. Okay. Area we can get from the diameter diameter is given 20 centimeter. Also convert into the meter and we can get the area of section 1, cross section area at section 1. Now pressure is given 39.24 Newton per centimeter square. Also convert into the Newton per meter square. 39.24 into 10 raised to 4. Z1 datum height 6 meter. Similarly, D2 is given 0.10 meters. Okay, 10 centimeter convert into the meter. So we can calculate the cross section at a datum at a section 2. This is the value of area 2. Z2 height 4 meter and we have to find out the P2. Okay. Now we have to apply the Bernoulli's principle at a section 1 and section 2. So we can get the pressure 2 at a pressure intensity 2 at a section 2. But we know that the three energy as considered: pressure energy, velocity energy and potential energy. So we don't have a velocity. So first of we will find out the V1 and V2 velocity at a section 1 and section 2. So we can find out from the equation of discharge. So because we have a discharge, so Q is equal to A1 V1 and Q is equal to A2 V2. So we have a discharge value and cross section area. So we can get a V1 and V2. Okay. So we can get the value of V1 and V2. Now we applying the Bernoulli's equation at a section 1 and section 2. So pressure energy, kinetic energy and potential energy. Similarly, pressure, kinetic and potential energy at a section 2. Okay. Now put the all values of all element of equation. Okay. So only P2 is unknown and so we can get the value of P2 after solving this, and we can get the value of P2 is a 14.27 Newton per centimeter square. Okay. We can get the value by Bernoulli's equation. Now we solve the second problem. See what is given into the data. Water is flowing through a pipe having a diameter 300 mm and 200 mm at a bottom. Okay. So 300 mm diameter at a bottom and 200 mm diameter is upper. Okay. That are mentioned into the figure. Okay. This is a 300 diameter and 200 diameter. Okay. The intensity of pressure at a bottom end is 24.525 Newton per centimeter square. Okay. Now, pressure intensity at the upper end 9.81 Newton per centimeter square. Determine the difference in a datum head if the rate of flow through pipe is a 40 liter per second. The rate of flow Q is given 40 liter per second and we have to find out the difference in a datum head. So we have to find out the value of Z2 minus Z1 datum difference. Okay, Z2 minus Z1. So again we have to apply the Bernoulli's principle at a section 2 and section 1. So we have to value of pressure, velocity. So we can get the value of difference of datum head Z2 minus Z1. Okay. So we have a value of pressure but we don't have a velocity. So again we have to find out the velocity V1 at a section 1 and V2 at a section 2. Okay. Now applying the Bernoulli's principle, simply put the known value of all elements only Z1 and Z2 have no value. So now take a difference of Z2 minus Z1 and rearrange the all values in this equation. Now we can get the value of datum head difference Z2 minus Z1 13.70 meter. So now we can easily solve this kind of applications of problem by the Bernoulli principle. Okay. Thank you, friends. I hope that you all very well understand the Bernoulli's principle statement and its proof and how to solve the examples of Bernoulli principle. You all very well understand. Okay. If you have any query, then feel free to